So one of the nice things about mass and energy balances is that we really only have one equation when it comes to mass balances, and it's the only equation you need to really memorize for this class. And all we do is learn how to simplify this equation so that we can apply it to multiple different processes. It's very, very powerful. And we call this equation the general balance equation. Sometimes you'll see me abbreviate this as GBE in class. So basically what the general balance equation is that we can balance out conservation of mass in a very specific way. So conservation of mass can be written as the input to a system plus whatever is generated in a system minus the output from the system minus anything that is consumed in the system will equal the total accumulation, right? So what you see second down is just a way of abbreviating that using capital letters. So it's a little bit of shorthand that I use sometimes in class. But basically the idea is that if something is going in, something also has to come out in a process. So input minus output will tell you what accumulated in the system. And then if we generate anything in the system and consume anything in the system, the difference between those is also going to have an accumulation. So general balance equation is input plus generation minus output minus consumption equals accumulation. And we're going to use this over and over again. It is the first step in every single solve for a mass balance. So let's talk really quickly about what those different balance terms mean in regular everyday terms. So an input is a quantity that flows into the process. It adds a total quantity to the process. That's why input is positive. So it's things coming into the system. Remember, our conventions are to draw an arrow coming in. So remember, it could also be written as an influent. That's a word that we always hear in environmental engineering. And it's something that's coming into the process. An output is a quantity that leaves the process. So it's the arrow that goes out of the box on our flow diagrams, right? And it's going to subtract a total quantity from the process itself. That's why output is negative, right? So it's pulling things out of the process. So the positive and the negative sign in the general balance equation are related to the process and what's happening inside the process. Generation is if we're adding to the process, but it increases the quantity within the process. So within the reactor itself, you can think of it as generating a new species or generating something in the process. So we can add something in, but then we can also generate within, and that's what generation means. Consumption is using up a quantity during the process. So that's if we're consuming reactants in a reactor, right? And that's going to decrease the total quantity. So that's important. So that's also going to be a minus sign. And then finally, accumulation is the amount of the quantity that changes as a result of the process. And accumulation can either be positive or negative. So we can lose a total amount of mass from the system if consumption and output are bigger than input and generation, but we can have a positive accumulation if the input and the generation are bigger than the output and consumption terms. All right, so signs matter quite a bit in the general balance equation, and these are how we define those 5 key quantities. We're going to do a quick little example of how to apply this in the next little pre-lecture, and then we're going to talk about how do we simplify this general balance equation so that we can apply it to multiple systems.